When I was in third grade, I was playing outside in the woods one day with a few of my friends, and we were having a really great time. We were playing pretty much every single game you can think of. But unbeknownst to me, I got bitten by a tick. Now, over the next few weeks, a bullseye-shaped rash started to appear on my upper arm, right about here. It was about this big. Naturally, my parents and I were scared. What was this thing on my arm? We went to a few clinics around our community. The first doctor just said it was some insect bite. The second doctor just said it was some sort of mosquito bite, but they were all wrong. Now, I'll go back to why this story is relevant in a little bit, but for now, I want to switch gears. Over the past few years, the world's been facing a lot of really severe problems. Global warming and climate change have contributed to rising global temperatures, and the rise in global temperatures has also led to an increase in a lot of natural disasters like wildfires. And an example would be the wildfires from Australia at the beginning of last year, which were some of the most devastating in recorded history. So finding new tools and new ideas to combat these new problems is more important than ever. And luckily, we do have something that can help us with this. We have the power of computers. More specifically, we have the power of artificial intelligence, or AI. Now, whenever I talk to my friends and family about artificial intelligence, I like to compare it to blockchain, because blockchain and AI are these two really advanced technologies that are kind of buzzwords, right? Everyone uses them. They're being used everywhere in commerce and even everyday life, like in Bitcoin. You probably heard of that. But no one really knows how they work, because Bitcoin is just, well, blockchain in general is just insanely complicated. But luckily, AI is really actually pretty simple. So the first research into AI really began soon after the end of World War II. So Alan Turing, who's a really famous computer scientist, created the idea of a Turing test. Now, the point of the Turing test is to determine if a human could not tell the difference between a fellow human and a machine, basically to see if a machine can act like a human in a given situation. Now, here's an example. Let's say you're part of an experiment, and the experiment is this. We put you inside of a room, right? There's a wall between you and the other side, so you can't see through the wall. But you can write on pieces of paper and send them through the wall so you can still communicate. Now, for the experiment, we put another human on the other side of the wall without telling you. And we tell that other person, hey, talk about whatever you guys want to for about an hour. So we let you guys talk about whatever you guys want to, maybe your dogs, your families, whatever. Now, at the end of that 1 hour, we pull you out. We pull the other human out, and we replace them with a machine. And we tell the machine, hey, figure out what this other person was talking about and copy them. That's all we tell the machine. Now, we let the machine go at it for another hour. At the end of that hour, we pull you out, and we ask, hey, did you notice anything weird or strange between the first hour of you talking and the second hour? Now, if you couldn't tell a difference between the human and the machine, then that machine has passed the Turing test, right? Because think about it. A fellow human, i.e. you, were not able to tell the difference between a human talking to you and a machine talking to you. So that's the entire goal of the field of artificial intelligence. We're trying to make machines that can act like humans. Now, soon after the invention of the Turing test, progress in the field really exploded. So just a few years later, we got the first AI algorithm, which was designed to play checkers. And just a few years after that, we got the first AI chatbot, and her name was Eliza. You can basically think of Eliza as Siri's great-great-great-grandmother. It was really old, but it did its job really well. Now, after Eliza, companies started to figure out that they could use AI in their business operations to save millions of dollars. So they started doing that. And more recently, we're seeing AI algorithms beat humans at some really popular games. Like in 2011, you might have heard of IBM Watson, which beat two of Jeopardy's greatest of all time players at Jeopardy. Now, while all of this research by the big companies was happening, smaller individuals, smaller corporations were also trying to figure out what they could use AI for. Because not everyone has $1 million to spend researching AI, right? So what could I or what could my small business use AI for? Now, there's one really interesting example of this that I'd like to share with you guys today, because it's really goes to show how we're using AI in fields that are completely unrelated. It's the case of the Japanese bakery AI. So in the early 2000s, Japanese bakeries were everywhere, right? If you were in a hotel in Japan, you could walk out, you'll probably see like 10 bakeries in front of you. Now, each one of these bakeries had food from across the globe. They had food from North America, South America, Europe, Russia, anywhere you can think of, they had food from there. Now, this is a great thing as a consumer, right? Because you want more types of product, because then you'll probably find something that you like, buy it, leave. But there was something else about these bakeries that really didn't mesh well with, hundreds of different types of food. You see, research has shown that when customers are presented with a product, they like it when that product doesn't have any, labels or wrapping or plastic covering or anything artificial, right? If I gave you two apples and one of them I picked from a tree in front of you, and the other one has pesticide on it, has plastic on it, labels, wrapping, what would you pick? Personally, I'd pick the one that was from the tree, right? And most people would agree with me. So the problem was that when a customer entered the bakery and they tried to check something out, the poor cashier would have to try to figure out what the customer bought because they had hundreds of different types of food and no way to identify them. So they were playing a matching game every single time a customer walked in. And over time, this was losing the bakery's money because customers had to wait like 45 minutes just to go in and out. Why would they wait in a bakery when they could just go to the McDonald's down the street, grab a coffee, and leave? So how did they fix this? They went to a company called Brain, which was an AI company. And what Brain did was create an AI algorithm to identify these pastries for the cashiers so that they could check out what the customer was buying and get them out of the door faster. Now, back then in the early 2000s, there were no off-the-shelf machine learning languages or models or anything. So Brain spent 10 years creating an algorithm from scratch. Every single layer, every single neuron, they built it themselves. It's like building a car with some sheet metal, screwdrivers, and like other basic tools. It's a really big challenge, but they managed to do it. Now, that part is really cool. Actually, if you go to Japan now, certain bakeries have bakery scan, which is what the model is called, in them. It's next to the cash register. It's like a little white box. It's really cool. So if you go to Japan, you'll probably find it. Now, this was really cool because again, creating an AI algorithm from scratch without anything to help you is a really big achievement. But something happened after their implementation of Bakery Scan that was really cool to me. So a doctor in Kyoto was at his house one day and he was probably watching something on the television and an advertisement came on for Bakery Scan. Now, the doctor's job was basically to look at cancer under a microscope and try to find patterns between tumors in different patients. Because if he could find a pattern, then maybe they could use that pattern to create a treatment for cancer. Now, he thought that cancer under the microscope looked really, really similar to these pastries that this bakery scan algorithm was designed to detect. So he reaches out to the team at Brain, and over the next few years, they changed that bakery algorithm to something designed to detect cancer. And you can actually see this algorithm in Kyoto too. If you go into a few hospitals, they might be using it to research tumors in a bunch of different patients. It was a really big deal, right? Now, I really like this story because it goes to show how we're using these AI algorithms in fields that aren't even related, like bakeries and cancer. You don't really put those together that often, right? But AI can be the thing that ties them together. Now, there are a lot of examples like this, but why would you be interested in AI, right? All of these companies, all of these hospitals, they have billions of dollars, right? They can afford the computer scientists to build these things. They can afford the complicated equipment to, again, build these things. What can I do? I'm broke, right? But that's the most important thing about AI nowadays. It's easier than ever to get started. And that's why I want to tie back to that story that I started with at the beginning of the TED Talk. So what happened was that tick had transmitted Lyme disease to me. I got Lyme disease. And that rash was a bullseye rash, which is a characteristic symptom of Lyme disease. But the problem with bullseye rashes is that they don't look like bullseye rashes. They're not constant. They can look like the insect bites that one doctor said. They can look like a mosquito bite, like the other doctor thought it was. So it's really hard for doctors to pin down what this rash is, and it's really hard for them to diagnose Lyme disease. But in my case, my parents basically forced the doctors to take a blood test, and that blood test finally revealed that I had Lyme disease. Without that blood test, I probably wouldn't have been treated, and I would have been stuck with some of the more chronic symptoms for the rest of my life, or I would have just died, right? But not everyone's as lucky as me. So this experience was really traumatic for me because, again, I almost died. So it was stuck with me through pretty much my entire life until 2 years ago when I was in 9th grade. So in 9th grade, our computer science teacher was talking to us about a field of computer science called computer vision. We were basically teaching machines to look at an image and figure out what was in that image, right? So I had an idea. What if I could use this field of computer vision to create a model to identify these bullseye rashes? Because if clinicians could use that model to identify these rashes, they could identify Lyme disease faster. And if they could do that, they could do treatment faster and save lives. One small problem, I knew nothing about computer vision, computer science, or programming. Because again, I was a 9th grader, right? What do you want me to do? So that didn't stop me though. I went to a lot of my teachers because at my school, we have senior labs and seniors work on machine learning projects. So I went to those senior teachers and I asked, hey, can you give me everything you have in terms of labs or stuff for AI? And they're like, yeah, sure. What are you going to do with it? You're a freshman. So they just give it to me. And I didn't understand anything because it was calculus and I was basically doing algebra in 9th grade. So I was lost. But again, that didn't stop me. I went online to Coursera and edX and I took courses from them. And they were all free. I took every single free course that I could because, again, 9th graders don't have that much money. I'm completely broke. So I spent an entire summer doing all of that. And I got the basic understanding of artificial intelligence. Now, again, I didn't understand any of the math behind it, right? I don't even like math. So understanding calculus and derivatives and integrals, yeah, no. So I just focused on how to make AI algorithms and how to use them. But at the end of the 3 months, I got the basic knowledge that I needed to work on this project. So the next step was to reach out to AI researchers and Lyme disease researchers to see who could help me. But again, I was a 9th grader, so why would a researcher spend hours and hours of their valuable time to help me, right? What could I do to help them? So I talked to about 100 different professors. I sent emails out like every single day. No one responded. But there was one researcher who finally got back to me, and they were a researcher at the NIH. They were super nice. And they said, hey, this is a really cool idea. So they helped me with it. We created a database of Lyme disease rashes because by then there were no databases like that. That was the first one in the world. We created the first Lyme disease database in the entire world. And using that database, I created an AI algorithm to diagnose these Lyme disease rashes, right? I even put that algorithm into an app so that people from across the country could literally just take a photo of a Lyme disease rash and diagnose it on the go without any internet access at all, right? Because in some places with Lyme disease, there is no medical infrastructure or internet access or anything like that. So it's actually being used now in clinics across the country. We're working on getting it, out of the medical trials and getting into the hands of patients. So why am I telling you about this? You see, again, when I talk to people about artificial intelligence, right, they see it as this mystical, magical field that only computer nerds can get into, right? In 1950, that might have been the case. You needed like a PhD in math to understand anything that Alan Turing was rambling about, right? But nowadays, it's not the case. You can literally go online and you'll find 1,000 courses on AI and artificial intelligence and everything you need to know to start a project, right? When a 9th grader like myself can do everything that you need to know in 3 months with limited time, limited resources, and no money at all, imagine what you guys could do, right? You guys have much more resources, many more contacts, much more things that I ever had, right? A lot of AI scientists think that AI algorithms are going to become better than humans in a lot of different aspects of society, right? But right now, that's not the case. AI is like nowhere near the Terminator level of intelligence that you see in the movies, right? I mean, I wish, but yeah, no. But line by line and training example by training example, we're getting there. But we're gonna need new people to understand how these AI algorithms work and how to use them and how to leverage them. And what really excites me is that the people in this very room could be the people who use AI algorithms to solve some of society's biggest problems, right? So just go home and spend an hour or two each week learning about AI or just reading an article, taking a course. Because in the long run, it's going to be one of the best choices you've ever made in your entire life. Trust me, I know. So thank you.